Hi guys, welcome to episode 4 of Psychology Made Easy Peasy. Today I'm joined with Dr. Haley Dimsdale Zucker, a postdoctorate researcher at Columbia University. If you want to introduce yourself, go ahead, feel free.
Sure. So my name is Hallie. I'm a postdoc at Columbia, as Leah just said. Um, I work on questions regarding memory and how memories are represented in the brain.
Yeah, we're just going to jump right into this. So in your research, what are the common tools or instruments you use to collect your data?
So I'd say in cognitive neuroscience, which is the field I most identify in, I should maybe back up a step just to say that people typically think about there being psychology and there being neuroscience. And it wasn't until I was relatively far along in college that I even knew the term cognitive neuroscience. So um, cognitive neuroscience is sort of, if you think about like the Goldilocks analogy, right? So I think about like true psychology is answering something really fundamental that can be measured solely with behavior, and true neuroscience being something like super detailed in terms of being like maybe at the cellular, the molecular level, usually working in an animal model. And I think about cognitive neuroscience as being somewhere in between those two. So I use some techniques that allow me to look at brain function and some techniques that allow me to look at behavior. And my work really tries to understand how the brain supports behavioral operations. So that's sort of the key of cognitive neuroscience. So as a memory researcher, I use a variety of different tools. So I do just behavioral work, so surveys and um, experimental work that I do both in-person data collection, and because of the pandemic, obviously we've done some online data collection. And then the neuroscience tools that I've primarily used in my research include functional magnetic resonance imaging, or fMRI, and electroencephalography, or EEG. Other people would use other techniques, including MEG, magnetoencephalography, transcranial magnetic stimulation, TMS, FNIRS, which I always forget what the acronym stands for, um, TDCS, transcranial direct stimulation. So there's a number of other techniques that I don't use in my own research program, but that definitely fit within the space of cognitive neuroscience toolbox.
Okay, and out of those tools, which do you feel is most effective for what you specifically look at, which is how memories are stored and how the process of memory storage works?
Yeah, I really think this is one of those cases where you need multiple tools to be able to answer the question. And more to that point, you need multiple people working on this from lots of different areas. So I just told you that I work in human subjects, but my work is hugely informed by animal models. So, it's unethical for me to go in and put a lesion in someone's brain, but sometimes to answer a question about whether a structure is necessary, it's really important to do that. And that is, more reasonable to do if you're working in a rodent model, or people even do it in non-human primates like monkeys. So I really feel like all the tools work together. And if I could only pick one, I don't think I would, right? Like, I think that
Yeah.
they all bring something different to the table.
Okay, that makes sense. From your experience with these tools and your research you've done, how would you answer the question of how and where are memories stored?
So I think if you had asked this question, maybe like in the 1950s, there would have been a very clear answer. People would have said memories are stored in the hippocampus. And I'm locating it to around like the 1950s, 1960s, because there was a very famous patient who was studied at the time. At the time, we only knew him as patient HM. He died, and I think maybe like 2008, something like that, relatively recently. And we now know after his death, his name was Henry Meliasen. And he had a form of epilepsy that was resistant to medication. And in order to help bring him some relief from his persistent seizures, there was an operation done to remove some of his brain tissue. I should say this is actually an operation that's still done now, but what's different about how this was done with patient HM is that the surgeon did a really unethical thing and took out too much brain tissue. And this caused not only the cessation or the stop of his seizures. That was the goal of the surgery, right? But there also was some impairments caused to his memory. And he was studied primarily by a couple of researchers. One was Suzanne Corkin, who spent her career at MIT. She unfortunately is now deceased. And Brenda Milner, who is, I think, at University of Montreal, and a number of other people. Anyhow, through the work that was done in HM, people really thought that because he was missing his hippocampus and he had memory problems, that the hippocampus was where memories are stored.
Mhm.
And then I think there came to be this understanding that that was sort of an oversimplification. So the hippocampus is a critical structure and can play key roles in memory storage and memory formation, but it's not the only player in town. So I really think about the whole brain working together. So like, let's take the example of you watching a TV show. You need to be able to perceive the information that's on the screen. So you need your occipital cortex, your visual areas to receive that input. You need to be able to reach into the semantic systems in your brain, the meaning-based systems to understand. So in temporal cortex, places like that. You need to use higher order brain areas to understand what's happening, like prefrontal cortex. And all of those things need to be brought together by integration areas. That's one of the things hippocampus might be doing. And then maybe some of those memories get stored, at least initially in hippocampus, but then you have a night of sleep and consolidation happens. And we think after a night of sleep or a couple of nights of sleep or months of sleep, whenever you're watching your TV show, that those memories may move from being stored only in hippocampus to being, I think of it like a backup copy is made in other parts of the cortex. And the way that those memories are represented in terms of being super detailed to being more schematized or a gist representation also shifts. So I like to think about the whole brain being really important to memory, but I think if you read like a very classic introductory psychology textbook, it would just say the hippocampus. But
Mhm.
I think that more and more we're understanding that that's an oversimplification of how the world works, how the
Right.
world works, how the brain works.
Right. So I guess coming off that question, so at that point, memories are stored in the hippocampus, but are also stored in alternative or different areas of the brain.
Mhm.
Is there a way for us to differentiate between these memories? I know you said that sometimes the memories are like the copy is created of the memory, which is not an exact replica of the original, like memory itself. What are these different kinds of memories, and how do you identify them in your work?
Yeah, so this is something that is still an area of a lot of debate. So some researchers think that there is a physical representation of the memory, maybe like a specific set of neurons, something like that. And they're going to call that the engram, ENGRAM. Other people say, wait a second, there's not just one cell assembly or just one set of regions that comes online when you're retrieving a memory or representing a memory. And there's some really famous work that's been done showing basically that you can remove cortex, you can remove parts of the brain, and people still have memories. So, you know, if you basically end up with like a Swiss cheese brain, then you should have removed a lot of memories, but that's not always what they find. This is work that's been done. It's a huge area of debate. So originally people thought that the more of brain tissue you remove, the more memories you disrupted. People then said, no, no, no. It depends when you do it. No, it depends where you do it. So that's really debated. Um, my own belief is that there are different traces that are represented. So different segments or fragments of the memory. And those are represented in different ways in different parts of the brain. But I don't believe that there is just one place the memory lives. So in my own work, I have asked questions about representations in memory, and I do think we can track representations, at least of some of the features that you're remembering. But I think that's a fundamentally different idea than saying the memory lives here.
Right.
Does that nuance make sense?
Yeah, that does. Okay, got it. Um, have you identified a difference between the subconscious and the conscious?
Again, I think about this being like a much older perspective on psychology. So when I was an undergraduate, I took a class in like a humanities department where we read like classic texts, and one of them was Freud. I never
Mm.
ever read anything from Freud in any of my psychology classes, which tells you something. And that was all about the conscious and the unconscious and the id
Mhm.
and all that kind of stuff. Um, and I have to say, like, I think about their things that we have conscious access to, like I can report back to you verbally. And I think about there being things that I don't have conscious access to, but I think about those existing maybe like on some continuum. So there's a lot of work, and this is where I really think brain imaging, particularly things like EEG that can give us a continuous measure of brain activity, can be really valuable because they can show us sort of like a ramping up of activity where, like, let's just say like memory recall, or you can do this fMRI as well. Like you can
Mhm.
get sort of subconscious, below the threshold of consciousness reactivation of information. And then you'll see it sort of surpass some threshold. I'm saying it like as if there's some number. There isn't really. This is just how I conceptualize it. And then you'll see someone recover that information. So I can give you two concrete examples of this. One is a beautiful line of work coming from Ken Norman's lab at Princeton, where they asked people to study, I can't remember now if it was words or objects or something. They studied a list of things, we're going to say, and these things were embedded within streams of pictures, and the pictures were either pictures of houses or pictures of faces. And they use this because you can really easily decode faces and places from some regions of the brain. And what they showed is that following that learning phase or that encoding phase, they asked people to retrieve those items that they had studied. And what they were able to show is that in the brain activity, they could actually decode the surrounding information. So let's say I studied, I don't know, the word red embedded within a stream of houses. When I was retrieving the word red, my brain would also show activity consistent with housiness and not
Mm.
activity of faciness. Let's say sometimes I was studying the word table, and table was studied embedded in faces. When I'm recalling the word face, then I would be also recalling or having brain activity patterns that are consistent with also bringing to mind this other contextual information. So I think about that being a real challenge to our ideas of what is conscious and what is unconscious. And I think it also shows the sort of layers or levels of memory, right? Maybe I could explicitly remember the word that I studied,
Mhm.
but in terms of patterns of brain activity, there's also information that's being recapitulated or brought to mind at retrieval that's shaping the way I remember that information. So, what in there is conscious and what in there is the subconscious? And the fact that maybe I can't tell you reliably, oh, the word red was studied next to houses, but I can detect that from patterns of brain activity. I don't know where that leaves us, right?
Right.
I think it really challenges us to think about that it's a pretty fuzzy line. So I
Yeah.
think when we read someone like Freud, or we hear about, in more of a pop psychology kind of thing, oh, that's in your conscious, or oh, that's in your unconscious, or oh, that's a
Mhm.
repressed memory, right? This is another term that gets thrown around in this vein. I really think we have to take a step back and think really deeply about it. And I don't think of there being like a really clean line that's a division between these things.
Okay. So based on your explanation, things like fMRI or EEGs can be used to detect like the difference between information being pulled from your quote unquote conscious and then information being pulled from your quote unquote subconscious, as blurry as that line may be.
Um, if that's what I said, I made a mistake. That's not what I mean to say. What I mean to
Okay.
say is that brain imaging techniques can be used to detect things that are sometimes not within conscious access,
Okay, got it.
and they can be used to detect things that are within conscious access. So what
Got
I
it.
mean is that if you can't verbally report something,
Right.
then we need another way of finding that information. People have been very clever and can use brain imaging, EEG, fMRI, things like that, to start to uncover some of those signals,
Hmm.
but you can't disentangle from those signals what is conscious, what is
And stuff.
unconscious,
Right. Okay.
and you can't like see all of someone's unconscious, right? Like I'm
Right.
telling you about like a very small fraction of studies where people thought really carefully when they designed the study, basically how they could like use or like leverage very specific tools within fMRI in order to
Hmm.
get back this information. My fear is that people think I can read their minds. There's no way I can read your mind. There's no way, we're not there. I don't think the technology is even going there. What I'm saying is in this very discrete, controlled experimental setting where everything else was controlled and I could, not me, Ken Norman's group could essentially tag your memories with this marker. They
Hmm.
could read back the marker they put.
Got
They
it.
couldn't read back anything else. Maybe in addition to thinking about houses and faces, people were thinking about their grocery list. They have no idea. They can't track that. Maybe they were
Right.
also thinking about the color green. They can't track that, right? So all I'm saying is in this very, very small, constrained way, they were able to track something that was brought to mind at the time that someone was retrieving a memory, even if people weren't actually being asked to verbally report or maybe couldn't verbally report that other information.
Right. I think this begs kind of a second question. And this is somewhat of a niche subject area, but I do remember while working with the Columbia Journal Club as part of the ALI lab, we did this activity where we had to draw a figure, and then 30 minutes later, we had to try to remember as much as we could and recall that information and draw it back. And I
Mhm.
know I was not able to draw the entirety of the figure. So I guess that brings me to my question of where does it go? Like when we forget something, where is it?
Yeah, I think about memory having sort of three phases. I think a lot of people would agree with this. So there's an encoding phase, there's a consolidation or like a stabilization phase, and there's a retrieval phase. And I really like using the analogy of like a watering can for your garden. So encoding is like filling your watering can, consolidation is like not having a rusty watering can, right? The water stays in when you put it in. And retrieval is like watering your plants, and we can have problems at any point in that system. So my hose couldn't turn on, or I have really bad aim and I couldn't fill my watering can, right? That's like an encoding problem.
Mhm.
I already told you a consolidation problem is like if we have a rusty watering can. And retrieval is like maybe there's leaves stuck at the top of your watering can and you can't pour it out. You can't get the water out. So memory problems can happen anywhere. Maybe you didn't robustly encode the shape. It's kind of this random shape. It's called the Ray Ostrith complex figure. And it's designed to be like impossible to just remember all of it. It has, for people who haven't seen it, like vertical lines and horizontal lines. And I think there's a weird smiley face and like a little tiny house, right? Like,
Yeah.
so maybe you didn't use a really rich or robust encoding strategy. You probably didn't, really study it in detail and make up a story for every element and really try to encode all the pieces. All I told you
Right.
to do is copy it. And then I didn't tell you anything else. I didn't tell you your memory is going to be tested. So it could have been that you weren't sort of doing a good job of getting it into memory. Could have been that you were so focused on paying attention to all the other exciting stuff that we were talking about in Journal Club, right?
Hmm.
That you just weren't prioritizing it. And I think that this is one of the things that, people get so upset when they forget, and really forgetting is so adaptive and so healthy. If you remembered every single thing from your day, just think about sort of how burdensome that would be, right?
Yeah.
Sometimes there's things that are really upsetting that we need to try to, put out of our mind, or even the mundane stuff, right? Like you don't need to remember the exact angle that your piece of toast was on your plate this morning at breakfast, right?
Right.
It's not important. So the brain's pretty smart, right? It says like, deprioritize. Like I don't need that information. So don't worry about storing it. We have a limited capacity. Or it could have been that I didn't give you a good retrieval cue, right? It could have been that I just said, that thing we did earlier, copy it, like, like show it to me, right? And
Right.
if I didn't tell you earlier, you saw a figure that had lines, I'd like you, and you drew it for me earlier, I'd like you to try to recover it from me again and redraw a copy. So maybe I just didn't cue you in a way that helped you remember all of that. So where does it go? Maybe it never got in the first place, and maybe it got deprioritized and it just wasn't something that got stored. Now, if I was thinking about stuff at the molecular level, where does it go? We think about memories being encoded via a real physical process where cells are
Mhm.
changing, this idea called long-term potentiation or long-term depression. So basically that means is there are actual changes in like the ways that neurons, these special cells that are in the brain, are wired together and are talking to one another, talking via these chemical signals. So the way that I think about it is at this much higher level, right? If my Goldilocks analogy is that I'm not a neuroscientist thinking at the cellular molecular level, I think sort of a couple of layers up. So that's more the answer I gave you. But if you asked, someone who's thinking about what's going on at the level of cells, they might give you a really different answer. And they might say, well, that means that the two cells weren't firing in coincidence with one another. Therefore, they weren't wired together. Therefore, like the memory was never sort of written down in this system. So I think both answers are valid. And I think, um, we're all at some different level of the Goldilocks hierarchy. So whichever way you're better able to conceptualize that, I think is a reasonable way of explaining that to yourself.
Understood. Okay. A lot of this research obviously has implications for people that struggle with memory loss. So I'm wondering what your work with the process of how memories are stored and how we're able to recall these memories and how cognitive neuroscience writ large can be utilized for greater societal purposes.
Mhm. So this is a question my family loves to ask me, like, um, kind of like, why is your work important? And I think what they want me to say is because I'm curing Alzheimer's and it'll be done tomorrow, right? And that's not my answer. Not even like, not only will it not be done tomorrow, I don't personally work on questions related to Alzheimer's. But what I do work on are basic memory questions. And, you know, if you've ever had like your car break down or your computer or some appliance, imagine trying to fix it without having a manual, or maybe no one has a manual these days, without being able to Google your problem,
Mhm.
without anywhere in the world there being sort of knowledge about how something could be fixed. Think about how hard it would be to fix your issue, fix your car, fix your computer, whatever. That's kind of the state of the world with the brain right now. We don't really even understand how it works in a healthy, typical situation. And we have all these disorders that seem to involve the brain. I just
Mhm.
gave the example of Alzheimer's. There's many, many, many others. So I view my work as writing the manual. So my work does not directly contribute to bettering the lives of people, but my hope is that my work helps build a foundational understanding of how processes like memory work, which will then, in general, enhance our understanding of how memory works, which other people will be able to build on and use to leverage to understand memory and to help individuals with memory impairments. I think one researcher whose work exemplifies how you could even make this transition in your own career is a faculty member who's at University of Toronto, Morgan Berens. So Dr. Berens's work is about really basic features of memory that like only memory researchers kind of think are cool, like configural processing and what do different parts of the medial temporal lobe do and what does perirhinal cortex do that hippocampus doesn't do, like real nitty gritty basic science stuff. But Morgan's work also, she's also using basic things we know to help people remember information better. And she's developed this whole line of work looking at what are more effective memory cues for individuals who struggle with memory problems like dementia and Alzheimer's diseases. And she has this technology she's been developing that she calls the hippo camera, which is a pun on the word hippocampus, that essentially is wearable technology that's taking photographs of people's day. And she wants to use basic information we know from memory research to know which are the most effective pictures to cue people with. When should we be cueing people? How often should we be cueing them? Should we be using space versus masked practice? So she's taking sort of, stuff that she could have read from the memory manual that we're all writing and applying it to a population that has a memory deficit. So I think that's one really cool example. Dr. Brenz's work is the exception, not the norm, right? We're not all going to develop a really cool thing. Morgan's brilliant, and I think that's why this has worked for her. But that's just one way that you could take the sort of my example of building the manual and using that to like leverage thinking about how we could improve memory for individuals who struggle with memory problems.
Got it. So, as an undergraduate, did you complete your like first 4 years as a psychology major or something else?
So I went into school undecided.
Okay.
My best friend in college was a theater major, and I used to hang out with her and her theater friends all the time, and they all knew each other. Right? Her theater department was super small, and so I was like this outlier stranger person, and they'd be like, who is this Hallie girl? So my friends started calling me an undie, an undecided. So I was an undie for probably the first 2 years of college. But I went to the University of Michigan, and they do a fantastic job of getting undergraduates involved with research. And so basically day one of college, I had gotten involved. Before I went to college, I was a camp counselor for individuals who are on the autism spectrum. And I think partially through that experience and partially just whatever people's interactions with me, everyone was like, Hallie, you're going to be a psychologist. And I was like, I am? Like, I don't know if that's what I want to do. But I thought, well, I got into this research experience program, and I guess being a psychologist, like being a therapist, that's the psychology department. So I guess I should try to do research in the psychology department. At the time, I didn't really understand the difference between like psychology research and being a psychologist.
Right.
Which the difference for other people who might be listening who also don't know that difference is essentially like one, you're doing research, you might be seeing people, but in the context of ask them to do an experimental study. The other is more like talk therapy or cognitive behavioral therapy or something like that. Anyhow, so I started working in a lab, and I just totally got hooked. I have to actually admit that when I first started working in a lab, I thought I was going to hate it. I thought people who did research were like really weird, antisocial, like people who would never be able to make conversation. And I was like, I'm just doing this to like discover that I hate it. And jokes on me, I discovered that I loved it. So I worked for 4 years with a phenomenal researcher, Dr. Patty Reuter-Lorenz, and I worked in a number of other labs there. So it was really that experience that convinced me that I loved doing this. And I switched from being an undie to being undecided to doing at Michigan. Maybe this is where my Goldilocks analogy comes in, but there's 3 different ways you could major in psychology. You could be a psychology major. When I was there, it was called a brain behavior and cognitive science major. I think it has a new name now, or a neuroscience major. So I was the middle, the brain behavior and cognitive science. And then somewhere along the way, I got really bored of just reading textbooks, and I missed reading just books. And so I also was an English major. So I was a double major in English and BBCS and brain behavior cognitive science, which for me was a really nice balance between the science and the sort of more creative stuff. I mean, I think science is also creative, but reading a textbook doesn't really like get your creative juices flowing the same way like reading a novel does.
Right.
And I've always been surprised at how much my experience in one has influenced the other. So being an English major really taught me close reading skills and writing. I do a ton of reading and writing now as a scientist. And so not only did I enjoy reading novels and 18th century poetry and James Joyce and whoever else, it also really has made me a better scientist. So I think for people who are listening and thinking like, oh, I have to have XYZ major if I want to go to grad school or if I want to go on in a particular field. I had a professor in college who said, scratch your itch. And I think that's really great advice. He was like, do the thing that gets you excited. What are you passionate about? And I think an undergrad is a great time to take a diverse range of classes and figure out what that is for you. So, I also took sociology classes, and I took a dance class, and I took, oh my God, it was so long ago. I don't remember what else I took, but just like go figure out what your passion is. Maybe you have more than one passion. Like try it all out. Don't feel like you need to be limited. You don't need to have your major on day one. I certainly didn't. You can change your mind. That's totally fine. Most of the people that I graduated with are actually doing nothing at all that has to do with their major. So I think you should really just focus on, getting a good education and practicing the skills that are going to be useful for whatever you decide to do.
Yeah. For students that might be already like dead set on cognitive neuroscience or some facet of neuroscience, what resources would you recommend a typical high schooler to maybe look into for them to get more information about this field, or just like get a feel of what researching or just learning about this information is like?
Yeah, again, I'm probably like the worst person to ask this question of, because I had literally no idea what I was doing in the transition from high school to college. So I was so unaware to even look for resources like this. So I would say, well, let me plug one thing my colleagues at Columbia are doing that I'm so proud of the graduate students. They're also putting out a podcast that's actually supposed to answer questions about what it's like to be in a PhD program and how to get into a PhD program, and trying to sort of expose some of that hidden curriculum that can be a barrier to entry into academia. And oh, they're going to kill me. I don't remember the name. I think it's called the Psychology PhD podcast. I'm going to say that. If you look on the Columbia psychology page, it should be featured there. Emily and Akawita is doing some of that, and Monica too is the current host. They're doing such an amazing job. And Arlene is also writing some of the episodes. Anyhow, real group effort. So that I know is a great resource. I trust the people who are doing it. They're putting out really good content. And they're all graduate students or people involved with the graduate department. So it's very firsthand. The other thing I would say is just try to, when you get to campus, like try to get involved with research if you can. And a good way to do that is like if you take someone's class and you do well in it, approaching the professor and saying, I'm really interested in working in your lab. Do you have any openings for volunteers? Or going to office hours and trying to build a relationship with people. That was one thing that I did. You can go to office hours even if you're doing well in the class. You might just have a question, or professors love when you show up to office hours and just say like, I like the question you just asked me. I'm really interested in cognitive neuroscience. Like, what else can I do? And that my intro to cognitive neuroscience, sorry, intro to cognitive psychology professor, Dr. Bill Gehring,
Mhm.
at Michigan, really inspired me to go and like attend a conference. And I was like, what is a conference? And he was like, oh, like a conference is like where academics come together and share information. Or when I went, I just like, my eyes were like popping out of my head. I was like, it's like my textbook came to life, and like everyone in the pages is here and they're just showing their work. It's so cool. So I think talking to people, trying to build relationships. If you can't build a relationship with a faculty member, try to build a relationship with a grad student in the lab, something like that. And I would say, there's a lot of different things you could be studying. And so taking a broad range of classes. So maybe you go in thinking you're really interested in social psychology, but you take a class in developmental and that ends up being your passion. So trying to sample widely, um, even if you're only sampling in the like psychology and neuroscience space.
Got it. Well, thank you so much for coming and joining us today. This was an amazing discussion. I appreciate you giving me your time and all the listeners. Um, I guess this is it. Thank you all for tuning in. And this is the end of episode 4 Psychology Made Easy Peasy. See y'all next week. Bye.
Bye, Leah. Thanks for having me.
Of course.